85 volts, 90 volts there. So turn the power off and this is what the screwdriver method does, which it's not recommended. Now if that had 150 volts in it, there'd be an even, a bigger arc off that, but if I zoom in you can see what it's done to the terminal. It actually blows pieces out of every time you arc it. If you use a screwdriver or something like that, it'll blow a piece out of either the terminal or the top of the capacitor, or if the capacitor's got enough power in it, it can actually blow the wire apart, or the clip, or whatever it is you're using. Melt cables, whatever, because the amount of energy that's stored in there, is actually getting out in one go. Now the reason you do it with a bleed resistor or a capacitor discharge tool is to avoid that massive big dissipation of power. So what you're doing is basically bringing it down slowly, bringing the capacitor down much slower, which in turn will cause less internal stress in the capacitor. 90 volts. Let's see, looking on the meter now, and 80, 90, 95 volts. So power off, and I'll just connect the negative side there, still on 92 volts on the meter. I'm holding this because I know what happens. Just hold it by the wire there so you can see, still on 91 volts, and if you look where I'm touching there, you get a little tiny arc. I'll do it again so you can see, just charge it up. .100 volts, power off, and if you watch the arc, the little spark on the capacitor, you might not have even seen it, it's so small, but the voltage is down in the millivolt range already, so that capacitor is drained. The resistor is stone cold, so all that power has been controlled